Welcome to a new video in my home automation and OpenHAT series, and Happy New Year everyone. I know this is not my first video in this year, but this is the first one I'm recording in the new year. And that's going to be part 3 of my NRMetric project. Part 1 was a summary videos, part 2 was all about the Node-RED flow, and this part 3 is going to be about the Arduino code. And back in part 1 I said that this was a project which really put my Arduino programming skills to a test, and in some cases I think I also failed a little bit. I mean, I'm not failed miserably, but I haven't created a solution I'm completely happy with. That's one part because of the communication between the Node-RED and the Arduino, or the ESP, is a little bit I would say sketchy. But the other thing is because it is not really reliable. Whenever I have any ESP devices, I try to configure the ESP so it sends the messages like the uptime and the RSSI back to Node-RED over MQTT, so I can monitor that. And what I usually do is I also monitor whenever the uptime goes back to 0, or well, actually goes back to a lower value, so that would indicate that the ESP has dumped and restarted. And that's what you can see here. And unfortunately, this is how this the display works at the moment. So you can see that after working for 1 minute, it restarted, and then 70 minutes and 59 minutes and 20, and then it basically goes all over the place. But in, you know, roughly it works for 20 minutes, 20 to 30 minutes, and then it restarts. And I managed to get these dumps in the Arduino IDE, and then you know, capture the dump in a serial monitor. I put it into this ESP exception decoder, and so all I could tell is that it's something happening within the TCP layer. So it must be related to the communication, either the MQTT communication or the HTTP communication between the Node-RED, and that is doing something, I don't know, in the memory or something which makes the ESP to dump. But that's all I could do on this at the moment, unfortunately. So if you go into the video description, you will find a link to the GitHub page to this Arduino project, so you can find the code there. And if you are experienced in these type of issues and this is something that you would like to help me, then well, please feel free to, you know, look at the code and make some suggestions. Or if you are rebuilding this project for your own, and if you manage to, you know, fix it, just let me know. And of course, if somebody is looking at this video maybe in, you know, in 6 months or 1 year down the line, you might even find the newer version which doesn't dump anymore. So obviously, when you go to the GitHub page, you will see the updates on the front page and the README. So if this is something that I managed to fix, then well, you will find it there. Before I dive into the code, I just want to give a short overview for somebody who is just planning to build this project and deploy this code without any real modifications, because there is only a few things that you need to change in order to make this code work for you. And the changes are really in the top of the code. So if you open the project in Arduino IDE, if you come to the really top one in the global declarations, you see that here you specify your SSID, your password, the IP of your MQTT server, your MQTT user ID, your MQTT password, and of course you can also change this. So that's the MQTT client ID. This is a topic where the device will publish a status message every 10 seconds, and that's the update topic where the device will request an update from Node-RED. So everything else here can be left as it is. And then also you need to come to the ntp.h here on the top, and then you need to set your GMT offset, your latitude and longitude, so it can correctly calculate your time zone based on the NTP request. Oh, and of course you can change this one as well, the pool.ntp.org. Sorry, I'm going to say this again later in the movie, because actually I'm recording this section after the other section. And there is actually one more thing which I sort of hard-coded into the code. If you remember, the first screen is always the time, or that's where the loop starts and ends, and that holds for 10 seconds, and that's something that I actually hard-coded into the code. So if let me find that method, which is called the handle display. Yeah. So if you come to the handle display method, and after this else section, you have an if sec greater than 10. So if you want that time to be shown for longer, then change this 10 value. So and of course, yes, you need to change your icons, and updating the icons is a little bit more complicated. So I'm going to talk in the end in more detail about that, how you do that, and that's pretty much it. I mean, the only other thing I have up in the main declaration section are the colors, and then again, these are the colors that you reference to in the Node-RED code when you specify the message.display.color. So 0 is white because here in the matrix I defined the first one as matrix.color 255.255.255. So you can specify any color here using the RGB values. I wanted to keep this video short, but actually if I'm asking somebody to help me out, maybe I should actually spend a little bit of time and then explain the code in a more detail. If you want to build your project on your own, then here on the top you can see the libraries that are required. So obviously I need all the ESP libraries, the PubSub libraries, the Adafruit graphics, and the NeoPixel library. The font, and I use the TomTomb font, which is the 3x5 font, so that's a really small one, which where the main, all the information is printed on, not the clock, but all the rest of the screens. I am using the UDP for the NTP functionality, so to get the network the real time. And then there is a few more stuff for managing time, sun, moon, because my NTP library was also calculating sunset and sunrise, not that I'm using in this code. And besides the INO file, I have two files: the ntp.h, which handles all the getting the up-to-date time for the time server. And the only thing you need to remember here is that up here on the top, you maintain your NTP server address or the pool address. So you can just leave it on pool.ntp.org or just use your country code to get a local server. You maintain your GMT offset and the latitude and the longitude, so it gets the correct time zone. And then I'm also using another include, which is the icons.h, and that contains all the icons that are appearing on the left side of the screen. So these are the icons that are associated with each screen. Here you can see the within the comments I'll just have the IDs, so 0, 1, 2, 3, and these are same these are the IDs that I use within the Node-RED code to define the the message.display.icon property, or attribute. So I have all my icons defined here, so that you can quickly modify if you want to have your own icons, which you probably need because some of them are really specific to my application. In the global variables, I also have some stuff that needs to be set. Pin matrix, so that's the pin that I use to connect the NeoPixel display. Again, I'll have the part 4 of the video, which is going to talk more on the hardware side of it. And then next, the generic declaration side. So again, SSID password, your MQTT server ID, MQTT user ID password, the MQTT client ID, and then you have a status topic. So in this status topic, every 10 seconds it sends out some information like what's the uptime, what's the RSSI, and what is the brightness level, which is being sensed by the photo. I think it's a photoresistor which is connected to the analog pin of the ESP. And that's the update requests, which again goes back to the Node-RED flow. So this is the topic where I send the IP address to, and then once that is received in Node-RED, then it starts sending out the updates to the ESP. So further down in the code, in the globals declaration, I have some arrays defined. That's probably, again, not a really nice way of doing this, because I'm not allocating the memory dynamically. I'm just creating these arrays, assuming that you would have up to 40 pages in any of your recipes. So that's obviously an assumption, and there is no validation on the code whether you are actually doing 40 or 41. So if you do 41, then your ESP is going to crash because it's trying to write to memory which doesn't exist. And the reason they have these values, because so this graphics 25 is, I think it's a Wi-Fi sign. 25, I said, yeah. 25, oh, no data. So the reason I have these values, because if, let's say this screen boots up, then obviously it tries to get the updates. So it starts with a time screen and it tries to get the update from from Node-RED. And if it doesn't receive an update within that 10-second window by the time the time is displayed, then it will start doing the cycle. So I wanted to fill up this array with some meaningful values. So it would display an icon with a word empty in white color, and that screen is going to last for 255 seconds. And I set the max page to 0, so that it will only display that one single screen. And after 255 seconds, it would go back to the time and it would try to get the update again. So that's my way of sort of handling if Node-RED is not responding. And I have some other variables here. So what is the current page? Okay, so that's the index within this page. There is a transition step, page change. I think I'm going to reset most of these values in config anyway, or in setup, sorry. Page ID, there's some stuff for the messages, some variables to store times, so I know when I need to update the NTP. Yes, so the NTP is updated every hour. And I have the brightness analog, so that's the signal that I get from the digital input, sorry, the analog input. And some more declarations, so I use a timer, just as the 1 second timer, and then every 10 seconds I send out an update on the status, and the usual stuff, the ESP client, the MQTT client, the HTTP server, and the MDNS responder. So, okay, nothing really fancy here. So if you have a different model, then you can start playing around with these values. If, for example, your screen is upside down or the lines look weird, because they might be wired differently in terms of whether the lines are wired or the columns are wired in the NeoPixel display. But that hopefully should be in the, like, let's say in the listings that you buy it from. And by the way, Adafruit has a really good website on this one, which explains how these matrices are usually wired and what zigzag means in the columns. Next is my global variable for the colors. So again, these are the colors that I pass from Node-RED, so the color indexes, and the actual colors are described here. Again, I took this from an example. I haven't really changed them because I'm not using more than these standard colors. Obviously, these are not the colors that are being used in the icons, so these are just for the text. And maybe what I should do, maybe I just go through the methods one by one. So I do this refresh stats, which just puts the string together, which is like a JSON string. So these are the stuff that I send every 10 seconds into the status topic, this one. And as you can see, is the RSSI, the uptime, and the brightness, which is the value coming from the analog input. And I have another piece which renders the time, as in it just puts a string like this together, which is the hours in 2 digits colon the minutes in 2 digits, and that does all the calculation. So as you can see, the NTP this epoch is the time, the synchronized time that I get from the NTP server, and whenever I get an update, I also store the NTP update millis, so the millis in this variable. So within the hour, when I get the refresh from the time server, this is how I calculate the time. So I have the reference millis and then the time at that point, and I just calculate the number of millis passed from that, and I add it to the epoch, and then I start slicing that to get the hours and the minutes. And I also make sure that the hours have the leading 0 if they are below 10. So you can change this one here if you don't want like 0 2 hours, if you want like space 2 hours. Timer callback, so that's my 1 second timer, and I usually do this in most of my sketches. Maybe I could do it in 10 seconds, because I'm not doing anything here which needs to be done every 1 second. So as you can see, I'm counting these seconds, and if it's 10 seconds, then I send I do the refresh stats, and then I send this the value up to the MQTT server. So nothing really special here. Reconnect is the MQTT reconnect logic. Again, standard logic. I haven't really changed anything here. Okay, handle update command. So that's the piece in the HTTP server which handles all the updates that are coming from Node-RED. So these are the ones where I send that Node-RED sends a message saying that on page 0, this is the icon, this is the color, and that's the text. And that's being handled here. So I check whether the server has the request has an argument which is called the ID. I save the ID. I also put some message here which then gets printed to the serial. I had a lot more serial print, but I commented them out once it was working. So I saved the graphics as well. And as you can see, I just update the relevant arrays that I have defined in the global. So again, I just wanted to keep it simple. Instead of creating a custom object and then one single array, I just have like 4 arrays, one for graphics, one for color, the duration, and the text. And obviously they would have you would use them with the same index to get the information so for one single page. Let me go back. So as you can see here, there's no validation here whether your page ID is actually less than 40. So you can make the ESP to dump by sending embedded page IDs, and also the same for graphics. So it's not really checking whether it's an ID which actually exists in this array, but same for the other one. So yeah, but I think since it's like a control system, you control the Node-RED part of it and the ESP, I shouldn't have too much logic in here. So you do the same with a page, color, the duration, and the text. So that's all comes in the HTTP request. If you get a message which doesn't contain any of these arguments or parameters, then you get a message back which says invalid call. Otherwise, I just send out an HTTP response 200 with a message. And that message obviously doesn't really get processed in the Node-RED side. And also normally the messages would have either an ID, a graphics, a color, and the duration, or they would have the max page. And if we add a max page, I just set my internal max page, which I'm using internally to know what is the last page ID. So again, as you see, pretty simple code. Nothing overly complicated. And I also put something in the serial so I know that an update has been received. Okay, we already got to the setup part, so that's going to be quick. So first I set up the serial line, I set the uptime to 0, all these counters to 0, the current page to 0. I initialized the screen. I took most of this from an example. So again, the begin a text wrap to false. So again, that ensures that if you have a long text, you know, more than 6 digits or something like that, then it just falls off the screen, so it's not, you know, being wrapped around and then magically appearing on top of the icon. That's the thumb font, so that's the 3x8 font. And initially I set the brightness to 30, so it will always start with a brightness. And I also want to mention here that what I've noticed is, so this set brightness controls every single pixel right to your screen, so your text, your icons, whatever. So actually it's really, really nice because you can set like a global variable, and then everything you write to the display would take this into effect. The only thing I've noticed is the within this library, the way they implemented the fade and I think it's the gamma curve or the chrome or something is not really correct, because for example, if I have a yellowish color, but if I use a really low brightness, it turns to reddish. And also if I have like really faint colors, then at low brightness they really go, sometimes they even disappear. And these screens are so bright. I mean, I'm starting the brightness at 30, and later on you will see that sometimes this brightness goes down to 10, because otherwise it would just blind me if the screen is in front of me. So they're really, really, really bright. So you just have to experiment with your colors a little bit and then see how they work at low brightness. I do the text icon, okay, and I draw a bitmap. You probably have seen in the video that when the display starts, it starts with like a Wi-Fi message, and after a couple of seconds, once it connects to the Wi-Fi, there is a blink because it writes a few more other bitmaps, but then it happens so fast that sometimes it just appears as a blink. But every major part of the setup process is represented by an icon. So the Wi-Fi connection is the first icon. So that's just when we connect to the Wi-Fi. And then we draw a next icon when we set up the timers, but that's like a split second. And then so the timers and the HTTP server and the MDNS responder. And the next icon is the MQTT. Usually that also connects in milliseconds to the MQTT server. And then the last icon is getting the NTP time. And that could take some time, but usually that's also like really, really quick. So this is when I send a request NTP update. So this is implemented in the ntp.h, and it just sends an update, and the response is going to be handled later in the code. And I also initialize the calculation for the summertime. Oh no, sorry, this is the sunset. And I do a brightness check, so we haven't seen that, but right in the beginning I checked the brightness. So actually I've set the brightness to 30, and then this method is going to well, most probably change that. This callback is the standard callback routine for the MQTT, but in the current setup I'm not sending any MQTT messages to this display, so it's not really doing anything. It just you know, putting this information into the serial output, but it's not really processing it. Oh, there is a bit of a code here which I've probably left you know, from way back. Okay, handle display. It is my piece which, you know, does all the page transitions. And so what I do first of all, I have two main variables that controls how this method works. One is the current page, which is the index in all the arrays, showing which page I'm displaying. and I just came up with this number. So if it's 0FF, then that page is the time page. And I also have a boolean which says if I need to do a page transition, whether it's a transitioning in or transitioning out. So that's a boolean. So if the current page is FF, so that's the time page, and if it's page change, if I need to transition in the time, then well, I just put something in the serial that, okay, I'm transitioning in the screen. And as you can see here, I'm doing a really simple for loop here. So that's basically 8 steps when the time comes up from the bottom of the screen. And I am doing it in a loop here and not in the main loop, because I don't, well, first of all, hopefully I can keep a much better timing of the transition, so it always looks smooth, it doesn't look bulky, because the ESP is actually not doing anything else, well, other than the other than the timers. And the second reason is because I'm not expecting any communication from the outside world. So the fact that I'm not checking the HTTP and the MQTT in these what is it, probably half a second, is hopefully it's not going to do any harm. And as you can see, it's the same messages, and then so it's basically 8 times refreshing the screen, and there is a 40 millisecond delay in between. So once this is done, I set the page change to 0, I set the seconds to 0, which is being counted by the what do you call the timer, sorry, yeah. And I also send, and once the time has transitioned in, so this is the transitioning in code, then I publish the update request to the update topic, the update request topic, and I send my local IP, convert it to a string. So after sending the MQTT message, this part of the code finishes, because we have just done, displaying the time. So the execution will exit the handle display, and when it comes back the next time, I can handle the else part of it. So if the page transition is, let me check, yeah. So if the page transition is now false because we have transitioned in, then we check if we have if the seconds have been increased to 10. So that's when the 10 seconds for the time has elapsed. And then if that's the case, then we transition the screen out, and then again we do the same for loop. Well, probably not the same, because it's counting up and the other one is counting down, or the other way around. And I transition the screen out, and I say that, okay, now the current page is 0, so I go to the first page in the array, and I say the page change is true because now I need to transition this new page in. I reset the second counter, and then it goes. And so anything up to here is now responsible for transitioning the time in and out, and then things here is responsible for transitioning all of the other screens in and out. And it goes pretty much the same way. So it's checking if it's a page change, so if it needs to transition in the one of the screens or one of the pages. And so the only reason this is a slightly bit different, because I also need to draw the bitmap, and I also need to set a font and a font color, and then also print the text for the current page. But then the process is the same. So it's basically 8 steps, as the bitmap comes in from the font, or no, from the button, and then the text comes in from the front, and then it waits for 40 milliseconds between each step. And then it's pretty much the same. I turn off the page change because we have just transitioned in the page. I reset the second. I also check the brightness. So every time the screen changes, it checks the brightness. And then next one, I check whether the duration for that page has elapsed, because if it's elapsed, then it's time to transition the page out. So I'm doing exactly the same thing the other way around, and then once the page has transitioned out, then I increase the current page, and if we reach the max page, then I set the current page to FF, which then will transition the time in. So hopefully this is simple enough. I tried to keep it simple, even though that I didn't have this concept of the time page in the first version of the code. So this is why I came up with this idea that 0 hexa FF is the time page. I didn't want to have another variable for that, but yeah, that's how it works. So simple. Okay, brightness check. So it's really simple. So we read, we do a read analog 0. So we read the analog pin, and then we have this very simple method which, based on this brightness, this analog level, it sets the screen brightness to either 10, 20, or 40, and that sort of works. So it all depends on your, what kind of screen you have, what is the you have this black film in the front, so how black is that, how much of the light it blocks out, and of course, like, general illumination in your room. But I wanted to do something, so with 10, with the brightness 10, that means that at night, when the lights are off, it still does a decent illumination, but if I'm sitting in front of the screen, it's not going to blind my eyes. So it's not distractive, but I don't think I can actually go any lower than that. Handle and TP response is again one of the routines that I got from an example, and that it just monitors the UDP port, and then it looks for any packets that have received from the NTP server, and that's again some of the calculation that needs to happen to calculate the epoch, which is the millisecond time corrected by the GMT offset, and also the sunrise time. So that's the the official NTP time. And as you can see, whenever I receive this, I also store the update, the millis in the NTP update millis. So I know how much time at any point in time. I know when I have a millis value, and for that millis value I have a precise time, so I can calculate the current time at any point. Loop. Okay, well, we already got to the end of the code. That was quite quick. I thought it's going to be more complicated. So the loop is it's just doing the usual stuff. So again, a standard example code for HTTP and MQTT stuff. So we check if we have anything that needs to be handled in the HTTP server. Next, we check if for any reason we lost the connection to the MQTT server, and if it needs to be reconnected. And then we handle the display. And there is some simple stuff here. So again, I do the time calculation. So if my tick, or if my millis from the last thingy reached 1 minute, then I increase the uptime, and that will then will be sent out over MQTT. And that's the thingy where I check whether I have more than 1 hour elapsed from the last NTP update, and if that's true, then I send another update request. So these 3 parts, the HTTP server, the MQTT, and the NTP response responsible for any communication handling, and then this main place is the handle display, which does all the page transitions. And as I said, this handle display would exit immediately if the screen is transitioned in and out. So it's only during the screen transition when this logic actually holds the execution from the loop. And actually, because when one screen transitions out, the other screen transitions in, and that whole process takes about 1 second. So that for that 1 second, and none of these logics are executed. Well, I don't know, maybe that's a little bit long, so that could be one of the reasons where it is dumping, because then messages can, build up in the MQTT part of it. because I just realized there is quite a bit of an MQTT traffic, and then I don't know, this probably actually needs to read all the traffic and then handle the fact that none of these messages are for this particular display, and then within that 1 second maybe that builds up. Again, even though this looks like a really complicated project, this is probably my 5th or 6th ESP sketch, so I don't claim to be a really experienced ESP developer. Within the GitHub folder you will find an icons.png file, so that's what I use to edit all my icons in. So it's just a one big file, and you can see this is my Wi-Fi icon and the MQTT icon, and that's the that's one of the things which is displayed in the beginning. So that's like setting up all the timers and stuff, and that's getting the MQTT, sorry, the NTP update, and then various icons like the YouTube icon, and actually I think there is a few here which I'm not really using. So these are all the travel times. So I just have it like a car icon and just put the like different text or icons, so I know which, if I have multiple travel times, which one is which. So that will be temperature, max temperature, minimum temperature, currencies, sun, sunny, clear night, rain, snow, sleet, wind, fog, cloudy, partly cloudy. I think it's cloudy night. That's wind, like wind speed. That is my way of, like a solar panel and the sun. And then you can see all these icons. I mentioned it in the first video that whenever I have a weather forecast for tomorrow, I duplicated all these weather related icons, and I put this yellow corner on the top left corner. So I can visually know that this is for tomorrow. And actually, that's supposed to be my no data, I think, no data sign, but it doesn't look good on the screen. So I think I physically in the array I replaced it with the Wi-Fi icon. That would be sunset and sunrise. And for example, here in the sunset and sunrise, I use this faint gray color, which is probably like this gray, I think. I'm going to bring, okay, more. So it's like this one. And actually at brightness 10, this just disappears. It just becomes black. So it's not showing up on the screen anymore at all. And these last few icons are the ones for the stock. So I think this is the first one where I actually have like a background color, which, yeah, fine, doesn't really make any difference. So I usually do my create my colors here, and I think here I can also turn on the grid, so it just makes it easier to draw. And I just I tried like importing, finding a clip art, and I'm resizing it to 8x8, but it just becomes so fuzzy. So it's just easier if you use like a 1 pixel paintbrush and then do everything manually. And it's actually nice that you can have multiple colors, because it really makes it easy to add some different text here. Or for example, I had this for the YouTube subscribers, and I have this small V which shows the views, but that just changes too much, so I did not include that at the end. And so that's all about the colors. And then also you need a way to convert these colors to this special hex format, which is being displayed here, and that's what you paste in. And the way I did it is I was looking around, because I was sure that there will be an application which can convert between these two formats. And sorry, let me just mute my phone. And actually I found something, and I think I got it from GitHub, but I don't remember the link anymore. But it's this one, LCD image converter. Or you can see the what is it? refusion.com/LCD image converter. So okay, it looks nice. And the only thing I had to do here is that within the conversion, you have some presets, and I have to admit, I don't remember the exact details why I had to do this, but I did some Googling because there are various displays where the, as you can see, the red is stored in 5-bit and the green is in 6 bits and the blue is in 5 bits. And for some reason it didn't work for me, so I took one of the presets and I made a change to it. And I made a change to it here. So I haven't made any modification in the code, so I changed this matrix. So change your matrix so it looks exactly like this one. So just pause the video, and I haven't done any changes on the reordering, and then the image looks like this and the font looks like this, which I don't think it makes any difference, and the template is like this. So anyway, so it works like this, and I say that, okay, I want a new image, I create a new image. So I'm just going to resize to, let's say 8 by 8. Okay, that's fine. And then I go to this program and I select one of my images. So I just copy and I come to here and I say paste. So it pastes in, and then you so once you paste it in your image, you can go to conversion. So make sure that your this NeoPixel preset. So once you made the changes into matrix and reordering, you can save it as a new preset. So you can do that, and then you can do a show preview. And this show preview is almost the same as the code that we can see here. So I just copy this out and I put it into Notepad, and I couldn't really figure out, but I noticed that there is an extra byte in the beginning of each of the bytes. So I just use the replace functionality, and I say that I want to replace all the 0x00s to 0x, and then I do a replace all. So at the end I come to this 2-byte format, and that's exactly the same as this one. So I just copy this out and I paste it and say paste this into this array. So you can see that the two are exactly the same. Bit tedious process, but actually it's not. So again, if I just follow one more, so I select, I come back to this program, I close the window, I close this one, I say paste, options, conversion, show preview, copy the whole stuff out, paste, I say select, copy, so Control A, Control C, Control V all here, Control H for replace, replace all, and go back to the Arduino code, and then you paste it here, and you get exactly the same what I have already in, for the MQTT icon. And at last I want to show you what you can use the serial monitor for. So let me just disconnect and reconnect, so to reboot the ESP. So if you open up the serial monitor or whatever COM port that you have, that you are using, and I just stopped communicating. Okay, so well, obviously, right in the top when it reboots, you will see the normal message is like that is trying to connect to your Wi-Fi. What's the IP address, and then it's trying to connect to the MQTT, and so on. And once that is completed, then it's going to start this cycle of, you can see the page transitions are going to call in like this, like page 0 in, page 0 out, page 1 in, page 1 out, and then in between you will see these messages dotted in. So these are the status messages every 10 seconds. So that's the actual JSON message, JSON string, which is going out to the MQTT topic. So you can always get the RSSI, the uptime, and the brightness. So that's the brightness which it's getting through the photoresistor in connected to analog input 1. And I specified the baud settings to 115200, and we have to wait just a little bit longer to finish going through all the pages. I think I have about 15 or something, and it's quite dark at the moment, so it's like sort of like late in the afternoon and overcast, and it's not facing the window. So I mean, I think if I have like complete darkness, then it goes down to like 10 or 13 brightness. And of course that really depends on what kind of photoresistor you have and the pull down resistor, but so you can tune it. So I think we are sort of approaching the last screen. And yep, so I have done, so the update request sent, that's the message, that's the MQTT message, and then page update received, and then you can see that I'm receiving 15 page updates, and they are quite slow because if you've looked at my previous video, you probably remember that within the in the flow, so within the flow in the core, when we are sending out the updates, there is this delay, and when I recorded this video, this delay was set to 10 milliseconds, and I was thinking that maybe if I increase it, that would have an impact on how, you know, often the ESP reboots. I was thinking that maybe it can't process the HTTP request in 10 milliseconds, and then maybe the requests are piling up. So if I increase that, maybe that will help. But I haven't seen a major improvement as of now. So that was the reason these messages came like really, well, sort of slowly, because before that it was like, it's like almost like one big chunk of like, and then you had like 20 of these page requests or page updates. So again, we see that the request was sent and the updates are sent as well, and then you can see that is being updated as well. Now it's being overwritten by a page update. So that's how it works, and that's what you can see and how much you can debug in the COM port. And if I would have an NTP update, that would also show some messages here that the NTP update sent, NTP update received, and it would just also echo the updated time that it received from the NTP server. I also want to say that if I make any major change to this project in terms of really fixing the code, or well, somebody helping me to fix the code, so it wouldn't crash and it would be, you know, work much more reliably, or if I just increase the functionality of it, then I will post a follow-up video, and hopefully I would not forget to come here and then put a link, or, you know, put a card here, so you will see that follow-up video appearing now as a card in the top right corner. So I think that will be all about the Arduino code of this project. Again, go to the video description to find the link to the GitHub page. And well, thanks for watching. Obviously, thanks for helping if you can, and stay tuned for the last video on this project.